Can you see my screen? Boleh tengok screen tak? Can you see my second screen? Saya tak pasti sama ada boleh tengok ke tak. Boleh nampak tak second screen?
Boleh, Doktor.
Boleh. Alright, okay. Okay, so I know it's a bit hard for you dah almost pukul 6. Okay, tak apa. I go in gently only to chapter 1. Okay, I just give you a brief introduction a little bit. Okay, sebab saya faham. Reaction kalau belajar 4.30 dah pukul 6 ni memang mencabar lah subjek ni. Okay, alright. So, what do we learn in chapter 1? Okay, basically kita belajar the very simple basic basic things that you need to understand yang kita akan guna a lot in the next few chapters. Okay, so first of all, right, you will learn reaction rate, kadar tindak balas. Okay, because calculation, reaction engineering, nak design reactor, mesti kena tahu reaction rate. How do we quantify reaction? Like I said, right? Chemistry, kamu belajar reaction. Engineering, bagaimana kita nak quantify the reaction? Kita akan guna reaction rate. So that's where the quantification, the mathematics come in place. Then we will learn a little bit about general mole balance, basically the mother of equation. I call it the mother of equation sebab daripada satu persamaan ni, general mole balance ni, kita akan derive ataupun kita akan dapat at least to be honest, not that I want to scare you, but you will probably learn another 40 to 50 equation that comes from one equation. Sebab tu saya panggil mother of equation. Daripada satu equation ni, kita akan derive 40 ke 50 lagi equation. Why you have so much? Like I tell you, reaction tu diverse. Tukar jenis reaktor, tukar fasa, tukar temperature, tukar pressure. Equation dah jadi berlainan. Okay, and you are not expected to memorize this 40 to 50 equation. You are not expected to memorize. Instead, kalau kamu faham kan, kamu boleh derive je dengan senang. Tapi kena faham lah. Kalau kamu faham, you can easily derive this equation. So imagine your seniors, it's very doable because physical exam pun kalau dia faham, dia nak derive tu senang je. Tapi kena faham lah. You faham, you can derive easily. If you don't understand, it's a little bit hard. But the key is you don't need to memorize equation. Reaction engineering is nothing about memorization. It's all about understanding in order for you to derive the equation. Okay, so then kita akan belajar a little bit about the types of reactor. Yang tadi saya cerita batch, saya cerita CSTR, saya cerita PFR. Let me explain a little bit on how does this reactor looks like. Okay, so before we talk about reaction rate, we talk first about chemical reaction. Okay, so kamu kena faham, okay, reactor is to design for reaction. So you have to first understand how do we say a reaction has taken place or not. Okay, so as I told you before, as long as you put in a compound or compounds and after the reaction you obtain a new compound, then that means a reaction has taken place. Okay, or in a technical way, a reaction is defined as when a chemical species lost its chemical identity and a new compound is formed. Okay, so reaction ni is very diverse. The common ones are synthesis, decomposition, single replacement, and double replacement. So this is what you learn in chemistry. Don't worry, reaction engineering saya takkan tanya kamu jenis tindak balas. It's fine, you don't need to memorize. Yang kita kena faham adalah as I told you, quantifying the reaction in order to design a reactor. But of course, kamu kena tahu sikit-sikit lah. Kalau synthesis tu apa, kalau decomposition tu apa. Basically, erti kata yang paling senang, synthesis tu adalah dua atau lebih bahan yang dicampurkan. After reaction occurs, you will get one compound. Okay, decomposition, one compound, lepas reaction jadi dua atau lebih compound, dia decompose, dia akan pecah. Synthesis pembentukan dalam BM, sometimes I will use BM way to explain. Okay, let me explain first. My classes are all in English, okay, but sometimes I will use BM. Why? Because sometimes I think that the certain things are easier to be understandable when explained in BM. So why do I know this? Because actually I'm educated in sekolah kebangsaan. Saya sekolah kebangsaan daripada sekolah rendah sampai sekolah menengah. So if you realise I speak quite good BM, actually I'm a Nyonya Melaka also. So that's the reason why I speak quite good BM. Okay, so certain things I will explain in BM is not to say takut kamu tak faham. Sebab kadang-kadang saya rasa certain things are easier to be explained in BM. Okay, so certain time I will try to use BM. Okay, so contoh kata sintesis. Sintesis dalam BM pembentukan. Pembentukan mesti pembentukan satu bahan, synthesis. Okay, decomposition is pemecahan. Sebab tu kamu ada satu bahan, pecah jadi dua bahan. So decomposition. Third one is single replacement, double replacement ni when you have more than one compound, so they will displace and then you will form different types of product. Okay, so that's about chemical reaction, but you actually have more than this. These are the common ones, but you will have different types. So probably you pernah dengar oxygenation. Kalau oxygenation, definitely penambahan oksigen. Dalam BM, pengoksidaan. You tambah oksigen, oxygenation. Kalau deoxygenation, kamu remove oxygen, deoxygenation. Kamu ada hydrogenation, dehydrogenation, tu tambah hydrogen. You might have combustion. Combustion saya rasa kamu tahu lah kan, combustion, anything ada bahan, kamu tambah oksigen, suhu tinggi jadi combustion, pembakaran. Okay. Oxidation juga, bila kamu tambah oksigen, oxidation pun boleh berlaku. So kamu kena faham, kadang kamu tambah satu bahan, tindak balas dia boleh jadi bentuk yang berbeza. Okay, contohnya bila kamu tambah oksigen, it can undergo combustion. Kalau suhu tinggi, dia akan melalui pembakaran. Dia juga, tapi kalau suhu tak cukup tinggi, dia boleh mengalami oxidation. So, kalau oxidation, bahan yang terbentuk adalah berlainan. Kalau combustion, bahan yang terbentuk pun akan berlainan. So, kamu kena faham, kalau kamu design reaktor kamu, katakanlah kamu nak reaction oxidation. Tapi kamu tak design dengan betul reaktor kamu, suhu terlalu tinggi ke, or pressure is too high, you will get combustion instead. Kalau kamu dapat combustion, kamu tak dapatlah produk yang kamu nak. Okay, so that's very important to understand. Reactor design ni very sensitive to the types of reaction. So sebarang penukaran dalam tindak balas ataupun design reactor, you will get a different outcome. So imagine everything is about money in a plant. Any mistakes or any changes yang kamu tak counter dengan cepat, kamu tak dapat produk yang kamu nak, there's a loss to the plant. That's why I told you, investment in the process is always on the investment on optimizing the reactor. Okay, now let's talk about understanding how a reaction has taken place. Macam mana kita nak quantify tindak balas? Macam mana kita nak quantify tu maksudnya menomborkan benda itu. Okay, dan contoh kes ni menomborkan tindak balas. Okay, right. So bila a reaction occurs, okay, kita ada reactant, raw material, kita ada product. For reaction to occur, reactant has to react. So kalau reactant react, mestilah dia akan disappear kan, ataupun dia akan berkurangan. Tindak balas berlaku, dia akan bertindak balas. Raw material reactant akan disappear. It will disappear. So meaning let's say, awal-awal kamu letak 100 mol bahan A, katakan A itu adalah bahan mentah. Technically, after reaction has occur, 100 mol ni kenalah berkurangan. Maksudnya 100 mol, ideally kita nak 100 mol masuk, 100 mol A yang masuk, yang keluar lepas tindak balas adalah kosong. Kenapa? Kalau kosong maksudnya semua A saya telah bertindak balas. That's the ideal reaction. Okay, so that is reactant. So bila kita nak melihat performance reactor, kita akan tengok juga, kita akan quantify berapa reactor yang telah habis bertindak balas. On the other hand, when reactant has disappeared, of course your product is formed. So by right dengan masa, reactant akan berkurangan, produk akan bertambah. So waktu asal mungkin produk B kosong, lepas tindak balas akan ada katakan 10 mol, 20 mol, so on and so forth. Ideally kita nak sebanyak mana produk B will be formed. So produk reactant A disappear, produk B, okay, B product will be formed. Okay, so saya cakap ni dalam erti kata abstract. Okay, how do we quantify ini? We will quantify in terms of reaction rate. Okay, so mungkin sebelum ni kamu pernah belajar dalam CPP. Whenever you see the word rate, maksudnya dia mesti per masa. Apa benda yang kamu quantify tu akan jadi per masa, per time, per hour, per second, per day, so on and so forth. But your calculation, kalau kamu nak kira rate, kamu tengok jawapan kamu, unit tu tak ada per masa, confirm salah. So there's one way also, as I teach you reaction, I will teach you how are you to know whether jawapan kamu tu betul atau tidak. Sometimes in engineering, you can already predict jawapan kamu kira tu betul ke tak betul daripada melihat unit yang kamu kira ataupun dimension. Contohnya, kamu kira reaction rate, tiba-tiba kamu tengok jawapan kamu tak ada unit per masa. Kamu dah tahu confirm jawapan tu salah. Sebab rate whatever with the word rate, regardless reaction rate, flow rate, apa-apa rate, ada rate, mesti jawapan kamu dia punya dimension tu mesti per masa. Okay, one way for you to check your calculation. Okay, so in these terms reaction rate, sebab reaction ada produk yang ada disappear, ada formation. So this rate of reaction, it can be expressed in terms of rate of disappearance or rate of formation. So kadar tindak balas, rate of reaction can be expressed either rate of formation or rate of disappearance. Okay, so that's the first thing. Okay, kamu akan tengok banyak kali pasal rate of reaction ni. Okay, right. So first of all, apakah dia dimension dan unit? Okay, as I told you, rate of reaction sebenarnya, okay, rate of reaction ni maksudnya rate of disappearance dengan rate of formation. Kadar pembentukan, kadar kehilangan. So kadar tindak balas ada dua jenis, kadar kehilangan, kadar pembentukan. And these two rate, kita quantify dimension dia adalah concentration per time. So kata rate per time kan, so concentration per time. Mungkin kamu tertanya concentration apa? Sebab tu kita kena tengok kamu kira berdasarkan kepekatan compound mana. Maksudnya kalau katakan tindak balas kamu A menghasilkan B and you calculate based on concentration A, maka itu akan menjadi kadar kehilangan atau kadar pembentukan A. Kalau kamu quantify kepekatan A dengan masa. Okay, concentration per time. Let's say kamu nak kira berdasarkan B, kamu quantify ke concentration of B with time. So dia akan menjadi kadar rate of disappearance or rate of formation of product B. So kamu kena betul-betul faham kadar ni sebab dia adalah concentration per time. Concentration ni kena fokus. Kamu quantify concentration A ke, kamu kira concentration A ke, kamu kira concentration B dengan masa. If you kira based on A, it will be rate of reaction of A. If you kira for B, it will be rate of reaction of B. Okay, so nanti dalam soalan kamu kena betul-betul check benda ni. Kena make sure kamu faham how are you quantifying these rates. Okay, so it's concentration per time. Okay, so concentration per time ni kalau tu dimension. Kalau erti kata unit, okay, kamu dah biasa familiar, right? Concentration is usually mole per dm cube, mole per liter. So the unit for the rate will become mole per liter second. Let's say example of unit, mole per dm cube hour, for example, or American engineering unit, pound mole per feet cube second. Okay, so that's American engineering unit. Kalau SI, unit SI will be mole per liter second if it's SI unit. Okay, so again, to refresh back sebab another thing about engineering, kamu tu kena faham unit itu untuk memahami apa yang nombor itu maksud. Okay, so that's why in calculation, kamu tu kena faham tu. Okay, kalau kadar tindak balas, kepekatan terhadap masa. Kalau unit contohnya mole per dm cube hour, mole per liter second, so on and so forth. One. Second, okay, mungkin kamu kata fikir, just now I said right, the rate of the disappearance and formation depends on which compound yang kita nak quantify kan. Kita nak quantify A pun boleh, nak quantify B pun boleh. So mungkin kamu confused. Nanti kan katakan plan A dia quantify reactant. Plan B quantify ikut produk kan, berlainan kan, it become a very difficult thing. So what happen is usually kita standardize. Kita akan kira berdasarkan satu compound. Dalam design reactor kita nak kira kadar tindak balas, we will calculate based on one compound, which is what we call as compound A. Apa tu compound A? Okay, compound A is definitely raw material, mestilah reactant. Okay, so katakan kalau kamu ada satu reactant, of course reactant tu yang kamu akan kira kadar tindak balas. But let's say you have two reactant, okay? Nak ambil reactant mana satu? Mana satu reactant tu akan menjadi reactant A. Kita akan guna yang limiting reactant. Kamu faham kan tindak balas dia ada excess reactant, limiting reactant. Ataupun arti kata lain, kalau kita ada dua raw material bertindak balas, okay, kita kena tengok dia punya chemistry punya reaction lah, but usually akan ada satu reactant yang habis dulu. Sebab dia panggil limiting reactant. Reactant tu yang akan habis dulu. Kalau reactant tu habis, tindak balas dah tak boleh berlaku. So contohnya saya ada katakan tindak balas amonia N2H2 kan. Okay. Let's say kamu tambah N2H2. Okay. Kalau katakan N2 tu habis dulu, we call it as limiting reactant. Limiting reactant tu akan jadi kita punya A. Maknanya kadar tindak balas kita akan kira berdasarkan N2 itu. Sebab N2 tu kita dah labelkan sebagai A. Okay, so we call it as limiting reactant. Sometimes we call it as reference reactant juga. Okay, maknanya hanya satu reaktan sahaja yang boleh menjadi A dalam pengiraan kita. Okay, and second, kadar tindak balas ada dua jenis kan, rate of formation, rate of disappearance. Kita kena seragamkan juga, tak bolehlah plan A kira rate of formation, plan B kira rate of formation, tak boleh, dia kena standardize. So kita akan guna rate of disappearance. So kita akan kira rate of disappearance of A. So kenapa this is important? Sebab kamu kena faham, most of the time, okay, when the design of reactor, we will use this rate of reaction. So kita akan standardize, kita akan guna based on rate of disappearance of A. Ataupun arti kata lain, kita quantify, kita ukur berapa banyak kepekatan A yang akan berubah dengan masa. Itulah kadar tindak balas yang kita akan guna dalam pengiraan. Okay, so all this one nanti later kamu tengok calculation semua guna rate of disappearance of A in our design of reactor. Okay, next, reaction rate ni pula, okay, kan saya kata guna dalam pengiraan kan, dan menjadi kompleksnya ni rate of reaction, dia berubah mengikut tindak balas, berubah mengikut temperature, changes according to pressure and changes according to concentration, types of compound, types of concentration as well. And if you use catalyst pun kadar tindak balas akan berubah. So kamu kena faham kenapa ni jadi kompleks, sebab kalau kadar tindak balas berubah, design reaktor pun berubah, pengiraan pun dah berubah. That's why yang part yang susah ni, sebab kadang kamu buat reaction, kamu rasa senario A, tapi tukar sikit jadi senario B. Pengiraan pun dah jadi sangat berlainan. So that's why you kena really understand how does these changes affects your calculation. Okay, right. Okay, now understanding a little bit more. Okay, apa itu example unit untuk kadar rate of disappearance and rate of formation. Okay, so as I told you, dia mesti rate of reaction regardless disappearance, formation. The dimension is concentration per time. Untuk faham engineering ni, kamu kena faham dimension dulu. Bila kamu faham dimension, kamu dah boleh tahu dia punya unit. Daripada unit tu kamu boleh tangkap dah sebenarnya. So bila saya kata kadar tindak balas adalah concentration per time, so unit dia mole per liter hour, kilomole per dm cube second, pound mole per feet cube hour. Okay, so this is all the example of unit for rate of reaction. So again, kenapa dia concentration per masa? Sebab nak tahu kadar kehilangan bahan itu atau kadar pembentukan bahan itu, kita kira perubahan kepekatan dia terhadap masa. That's why kita tahu kadar tidak balas. Either kadar kehilangan atau kadar pembentukan. Right? Okay, so done. Next. Okay, now I say it a lot of times, right? Rate of disappearance, rate of formation. Okay, takkanlah dalam pengiraan nak tulis panjang-panjang kan? Rate of formation, rate of disappearance, it takes a lot of time. So we have a symbol to represent this. Okay, so this is also another added challenge of reaction. Dia banyak simbol. Sebab pengiraan kan, pengiraan kita tak boleh tulis panjang-panjang, dia banyak simbol. Okay, so how do we symbolize rate of reaction? Okay. Because rate of reaction ada dua jenis kan, rate of disappearance, rate of formation. Okay, rate tu kita guna R, huruf R yang kecil. R kecil means rate. Tapi sekarang rate ni ada disappearance, ada formation. Okay, you understand this in a very simple way. R tu akan menjadi negative R. The R become negative R for rate of disappearance. Kenapa? Disappearance kan hilang. Kamu bayangkan kalau benda tu hilang, dia akan menjadi negatif. Lalu dia jadi negative R, rate of disappearance. On the other hand, formation, something is being formed, something is added to the system, is a positive thing. So rate of formation, kita letak simbol positive R. So lepas ni bila kamu tengok negative R, ia bermaksud kadar rate of disappearance. You see a positive R, it means rate of formation. Okay, that. Next, kamu kena faham pula. kan saya kata the rate of disappearance, rate of formation is specific to the compound. So kamu kena letak rate ni berdasarkan compound A ke compound B. Okay, let's say kamu nak buat untuk compound A. So yang menjadi rate of disappearance of A, dia akan menjadi negative R subscript A. Ada A kecil kat bawah tu. A kecil kat bawah tu penting sebab maksudnya you are calculating the rate of disappearance of A. So negative RA means R rate, negative disappear A species A. So rate of disappearance of A. On the other hand, if let's say kamu nak tulis rate of formation of A pun boleh. So rate of formation, rate R, formation positive, A to show the compound A. So it become positive RA. So selepas ni bila kamu tengok negative RA means rate of disappearance of A, positive RA means rate of formation of A. So the positive and negative of the R to signify disappear of formation, the small a to signify the species that you are quantifying, which is A, your compound A, which is your reactant dalam senario contoh ni. Okay, now itu adalah simbol untuk positif atau negatif R. Yang kedua, since saya kata dia quantify kan, dia ada nombor. Kadar kehilangan, kadar pembentukannya ada nombor. Okay. Ini jadi masalah yang kedua. Okay. Nombor tu, the number, the rate tu, it can be negative or positive. Okay. So part ni mungkin sudah akan jadi confused. Okay. Kamu faham dulu. First part, dia belah kiri, belah kanan kan. Okay. Belah kiri, positive RA, rate of formation. Negative RA, rate of disappearance. Okay. Part sebelah kiri nombor dia kan, sekejap, kiri kan. Okay, saya pernah confuse kiri kanan. Okay, the number tu can be positive atau negatif. So mungkin kamu terfikir, saya nak tahu positif ke negatif. Okay, sekarang kamu tengok. Katakan kamu nak tahu rate of disappearance of A. Kadar kehilangan spesies A. Kamu cek tindak balas dia. A is a reactant, A does disappear. Kamu nak kira kadar kehilangan, rate of disappearance, and in the reaction, A does disappear because A is a reactant. The number is a positive number. Contohnya, let's say I put positive 10. So, positive 10 mole per dm cube second. Maksudnya, untuk tindak balas ni, kadar kehilangan A adalah sebanyak 10 mole per dm cube untuk setiap saat. 10 mole per dm cube for every second is the rate of how the A disappear. So nombor dia positif. Okay. On the other hand, katakan kamu nak kira kadar the rate of formation of A. Positive RA. Okay, tadi kita nak kira negative RA, rate of disappearance. Dan calculate the rate of formation of A. So the rate of formation of A, positive RA. Okay, nombor dia pula. Okay, again, kamu kena tengok. Peranan A, the role of A in the reaction. I want to know the rate of formation of A. But in the reaction, the A is reactant, the A disappear, the A does not form. It does not agree to one another. The number is a negative number. Now we put negative 10. So negative 10 maksudnya nak kira kadar pembentukan. I want to know the rate of formation, but A disappear. It does not agree, the number has a negative in front of it, negative 10. Okay, so kamu kena faham part ni. Kena faham part kiri, part kanan. Kenapa ada positive R, rate of formation? Kenapa ada negative R, rate of disappearance? Kenapa nombor ada positif, ada negatif? Dia negatif kalau dia tak bersetuju dengan what you want to find and the role of the species during the reaction. Okay. If you don't really understand this, tak apa. Kita pergi kepada B pula. Okay, katakan sekarang, kita nak kira untuk produk B. Let's say the reaction, you have reactant A. Tadi kita kira untuk A kan, kita pun boleh kira untuk B. Tapi dalam case ni, B adalah produk. Now B is a product. Okay. So you can calculate the same. Rate of disappearance of B, rate of formation of B. Kita tengok dia punya nombor positif dan negatif. Okay, contohnya, let's say now I want to calculate rate of disappearance of B. So tadi negative RA untuk A, kalau untuk B, negative RB. Negative RB means R rate, negative disappear, B compound B. So rate of disappearance of product B. So rate of disappearance of product B, kamu tengok balik. Dalam tindak balas ni, B is product, B is form. Kita nak kira rate of disappearance, tapi B is form dalam tindak balas sebab B adalah product. It does not agree to one another. The number has a negative in front of it, become negative 10. Okay, kenapa negatif 10? Sebab nak kira kadar kehilangan. Tapi dalam tindak balas, B terbentuk. Dia tak bersetuju, the number has a negative in front of it. On the other hand, if I want to calculate rate of formation of B, kadar pembentukan B. Okay, so rate of formation rate formation mesti positive R, right? So untuk species B, positive RB. So R rate positive formation, B is species B. So rate of formation of B become positive RB. Okay, saya nak kira kadar pembentukan rate of formation of B, and when I check the reaction, B is formed. Nak kira kadar pembentukan dan betul memang B terbentuk. That's why the number has a positive. Or you don't write positive pun tak apa, kita dah faham. Kalau tak tulis positive, kita faham. That means it's a positive number. So that's why you get positive 10 for positive 10 for rate of formation of B, but negative 10 for rate of disappearance of B. Okay, so I hope you can understand or you don't get confused sebab things will become a little bit more difficult. Okay, tadi tindak balas melibatkan A form B, A reactant, B product. Okay, sekarang saya bagi contoh di mana A and B adalah reactant, C dan D adalah product. Okay, sometimes memang part ni sudah a little bit confused sebab certain reaction B tu adalah produk, A reactant, B product. Ada satu tindak balas, kalau ada dua reactant kan, so B tu sekarang dah menjadi reactant. So kamu kena faham dia punya perbezaan. Okay, katakan sekarang, I have two reactant, two product. Okay, A dan B reactant, C dan D product. Okay, sama juga, saya boleh kira rate of formation and rate of disappearance untuk A, B, C dan D. Sama je. Kenapa kita boleh kira? Sebab katakan kamu tahu kepekatan C. Katakan dalam kamu punya reaktor tu, kamu monitor kepekatan C. Maka kamu akan kira lah kadar kehilangan C, kadar pembentukan C. Kalau kamu kira untuk D, kamu kira berapa kehilangan atau pembentukan kepekatan D dengan masa, kamu dapatlah kadar kehilangan, kadar pembentukan D. Okay, although I tell you, usually kalau dalam plant, orang kira A, orang akan kira kehilangan kepekatan reaktor A dengan masa, biasanya orang guna tu. Tapi up to you, kalau kamu nak guna C and D, kamu boleh kira juga. Tapi akan berdasarkan produk C, produk D lah. Okay, alright. So now, I want to calculate, let's say I want to calculate the rate of disappearance and rate of formation for my reactant, reactant A, reactant B. Okay, so rate of disappearance of A, negative RA. Rate of disappearance of B, negative RB. So negative RA, negative RB, the number will definitely be a positive number. Tengok siapa tu confused. Nombor dia akan jadi nombor yang positif. Kenapa? Rate of disappearance of A, rate of disappearance of B, and in the reaction, A and B does disappear. They agree to the number, they agree to one another, the number is a positive number. On the other hand, kalau you want to calculate rate of formation of A and B. So rate of formation of A, positive RA, rate formation of B, positive RB. And in this case, kita nak kira rate of formation, but in the reaction, A and B disappear. Nak kira kadar pembentukan, tapi A dan B tu hilang. So dia tak bersetuju dengan one another, the number has a negative in front of it. Okay, so kamu kena betul faham kenapa ada positif, negatif R. Kenapa nombor tu pun ada positif atau negatif. So, kamu kena faham apa yang kamu nak kira dan apa peranan spesies tu dalam tindak balas. Nak kira kadar pembentukan, dia terbentuk, nombor tu positif. Nak kira kadar kehilangan, tapi dia terbentuk, nombor tu negatif. Nak kira kadar pembentukan, benda tu hilang, negatif. Nak kira kadar pembentukan, benda tu terbentuk, jadi positif. Okay, so kena faham negatif, positif on the R and negative positive on the number. Okay, alright? Okay, so same for C and D. Tadi saya kira untuk reactant A dan B. Now saya kira untuk produk C and D. So produk pun sama. You can calculate rate of formation, rate of disappearance. So either negative RC, negative RD, positive RC, positive RD. Okay, so kalau negatif RC, negatif RD, rate of disappearance. Okay, tapi cek dalam tindak balas C dan D terbentuk. I want to know the rate of disappearance, but both of these compound form. They do not agree to one another. The number has a negative sign. On the other hand, rate of formation, positive RC, positive RD. Okay, I want to know how much is the formation of the product. Positive RC, positive RD, and you check the equation, the product is formed. I want to know the rate of formation and the product does form, okay? So the number will be a positive number. Okay, so positive number tu berapa kan? Itu yang kita akan kira how much the concentration change with time. Jadi kita kata kadar tindak balas adalah sebenarnya kadar kehilangan atau kadar kebentukan kepekatan dia terhadap masa. Okay, so this is something that you really need to somewhat understand sebab nanti dalam kita punya penyiraan ni kita akan sentiasa guna this rate of reaction. Okay, next thing is, okay, tadi saya beritahu kamu, I explain to you why the number can be negative, why the number can be positive, right? And I tell you it depends. Katakan if you want to, if you're in your plant, you measure concentration of B, jadilah kadar kehilangan, the rate for B can be disappearance, can be formation. If you, let's say you measure concentration of product C, so jadilah rate of disappearance, rate formation of product C. However, most of the time, kita akan kira berdasarkan A. Kita akan kira berdasarkan our one limiting reactant, which we name it as A. Okay, so katakan kalau kamu confused dalam soalan ke, dalam exam, macam nak tahu kan? Okay. Biasanya dalam persamaan kimia tu, the first reactant tu adalah limiting reactant. Most of the time unless stated otherwise. Biasanya kalau dia tak beritahu, okay, secara clear, you may assume the first compound dalam persamaan kimia tu sebagai limiting reactant, sebagai your A. Senang, paling senang nak tahu. Kecuali kalau soalan tu tulis clearly, okay, reactant yang kedua tu adalah kamu punya A, baru kamu ambil reactant kedua tu sebagai kamu punya A. Okay, so normally in the plant, they will quantify based on one raw material based on your A. Okay, so kita akan tahu apa? Kita akan tahu positif RA atau negatif RA lah. Dan biasanya untuk mengelakkan kekeliruan, to avoid confusion, kita akan kira negatif RA. Apa tu negatif RA? Negative R, R rate, negative disappear, A compound A. We calculate based on rate of disappearance of A. Okay, so that's standard. Okay. However, you can use this negative RA to calculate for other species. Maksudnya, tak payahlah kamu nak quantify semua compound. Kamu quantify A, kamu dah tahu kadar untuk spesies yang berlainan. Itu maksud dia. Means that, if I want to know the rate of other species, I don't necessarily have to kira kepekatan. Bayangkan kamu nak catat kepekatan A, kepekatan B, kepekatan C, kepekatan D. It takes a lot of time. You don't need to do that. In order for you to know the rate of other species, kamu dah tahu mana RA, dah boleh kira yang lain. Tapi macam mana kita nak kira? Okay. It is based on the stoichiometric coefficient. Okay, stoichiometric coefficient tu apa? Stoichiometric coefficient are the numbers in front of your chemical species in your chemical equation. So kadang-kadang kamu perasakan dalam chemical equation dia letak 1A menghasilkan 2B. So that 1 and 2 is your stoichiometric coefficient. Or sometimes they write 1A react with 2B to produce 2C. So that 1, 2, 2 is your stoichiometric coefficient. Kita boleh guna nisbah or the ratio of the stoichiometric coefficient to determine the rate of other species. What do I mean by that? Okay. Sikit lagi saya tahu kamu pun dah penat. Sebenarnya saya pun dah penat juga. A little bit more, I will finish by 6:30. Okay, 10 more minutes. Okay. Now, let's say kita dah tahu minus RA, kita nak kira untuk spesies B. Kita nak tahu negatif RB, katakan kita nak tahu positif RB. Katakanlah kamu dah tahu minus RA, tapi bos kamu kata, no, I want to know in terms of B. Okay, so maybe you think, oh, aku kena kira balik ke? Aku kena monitor balik reaktan B ke? Tak payah. Boleh je guna pengiraan, kamu dah boleh tahu kadar tindak balas B based on kadar tindak balas A. So what are the correlation? Okay. First, depends. You want to know rate of formation ke rate of disappearance? Kalau rate of formation, positif RB. Rate of disappearance, negatif RB. Itu benda pertama. Kamu kena betul-betul clear. Nak tulis kadar tindak balas tu, make sure write clearly. Negatif or positif R. Write clearly the species. Species B ke species A. Okay, that's it. You want to do for positive RB. Rate of formation of B. Okay, tengok B adalah produk dalam tindak balas ni. Kamu kena betul-betul tengok chemical reaction bila kamu nak buat pengiraan. Dalam this reaction, A reactant, B product, we want to calculate rate of formation of B, positive RB. Because B is a product, we calculate rate of formation. That's why dia ada positif di hadapannya. Nak kira kadar pembentukan. And dalam tindak balas, B memang terbentuk sebab B adalah produk, positif, nombor jadi positif. Okay, so positif, kamu kena kira nisbah, the ratio of B per A. B per A adalah nisbah stoichiometric coefficient dia. So contohnya katakan, the reaction is 1A produce 2B. So the B is 2, the A is 1. So positif kali dengan 2 per 1, multiply with your minus RE. So, kan saya dah kata, minus RE biasanya memang kita akan quantify. Kita dah tahu minus RE. So, kita tahu minus RE, kita darabkan dengan nisbah stoichiometric coefficient. Make sure the number positif negatif tu betul. You dah dapat rate for B, rate of formation. Okay. Let's say kamu nak kira rate of disappearance of B. Okay, so rate of disappearance of B, negative RB. Okay, R rate, negative disappear, B is for compound B. So negative RB sama dengan, first of all kamu kena check dulu nombor tu positif atau negatif. Kamu kena letak betul sign yang betul. Dalam kes ni, I want to calculate rate of disappearance of B. But when I check the equation, B is formed. B terbentuk, tapi I nak kira kadar kehilangan. That's why the number has a negative. Then, darab dengan, again, the stoichiometric coefficient ratio, B per A, and then multiply with minus RE. Minus RE tu nombor dia mesti positif. Kenapa positif? Rate of disappearance of A. A kan memang akan sentiasa hilang sebab A adalah raw material, A adalah reactant. A akan sentiasa hilang. So, kadar kehilangan A minus RA will always be a positive number. Okay, so that one kamu kena betul-betul faham. Alright? So, done for B. Next one, let's say sekarang dia kompleks pula kan bila masa B ni sekarang adalah reactant. So, kamu kata kadang-kadang saya kena bagi contoh. Contoh sebelumnya adalah bila satu reactant A menghasilkan satu produk B. Contoh kedua apabila A dan B adalah reactant pula. Okay, so A dan B reactant, C dan D adalah produk. Okay, dalam kes ni, kamu tengok nombor dia akan dah jadi negatif, positif tu akan terbalik. Kenapa? Sebab dalam kes ni, B adalah reactant. Maksudnya, if I want to calculate the rate of formation of B, okay, how much, the rate of formation of B, positive RB, then you check in the equation, in this chemical reaction, B has disappeared. I want to find formation rate, but B has disappeared because B is a reactant. It does not agree to one another. The number is a negative number, and don't forget, multiply with the stoichiometric coefficient. Contohnya katakan tindak balas dia 1A bertindak balas dengan 1B. So, B per A tu 1-1 lah. Atau contoh kata, the reaction is 1A with 2B. So B tu jadi 2, A tu jadi 1. Then multiply with minus RE. Atau kata lain, macam saya kata tadi, kita nak tahu kadar tindak balas lain, kita menggunakan kadar tindak balas A. Okay, so next, rate of disappearance of B. So rate of disappearance of B kan, kadar kehilangan B, and in this reaction, B does disappear because B is a reactant in this reaction. So it agrees to one another, the number is now positive. Then multiply stoichiometric coefficient, multiply with minus RE. So stoichiometric coefficient tu it depends on your reaction lah. Certain different reaction will have different stoichiometric coefficient. It can be 1A reacting with 1B. It can be 1A with 2B. It can be 1A with half B, so on and so forth. So the stoichiometric coefficient tu depends on the reaction, depends on the question. Okay, right. So next one, I think should be the last for today. Okay, last for today. For C dan D. Okay, so katakan sekarang kita ada produk C, produk D. We want to calculate the rate of formation, the rate of disappearance. Okay, so rate of formation, positive RC, positive RD. Okay, equals to the number, positif ke negatif? Kadar pembentukan, rate of formation, and C and D does being formed, they are formed. Hence, the rate of formation will be a positive number. But don't forget, multiply again with the stoichiometric coefficient. Tapi, kena stoichiometric coefficient of that species lah. Contohnya, if we want to calculate for C, it has to be the stoichiometric coefficient of C over A. Kalau you're calculating for D, it must be stoichiometric coefficient of D over A, and both cases multiply with minus RA. Okay, so let's say the reaction is 1A with 1B to produce 2C and 1D. So C per A will be 2 over 1, D per A will be 1 over 1, the ratio of the stoichiometric coefficient. Okay. Next one, rate of disappearance of product C and product D. So again, rate of disappearance kan, so negative RC, negative RD. Okay, so kamu kena faham part negatif positif R tu bergantung kepada what rate are you calculating. Rate of formation, positive R. Rate of disappearance, negative R. Then species C, species D. However, the number tu pula ada juga the negative positive depending again on the row of the species in the reaction. Amirul, kamera terbuka lagi. Amirul, Okay, thank you. Saya really phobia sebab ada sekali dulu kelas student tu buka kamera dalam toilet, so I become very phobia about this. So you don't mind kalau saya terus sound lah sebab saya dah kena sekali saya takut sangat. So make sure you really check your camera is not switched on. It's okay Amirul, saya takut tu je, tapi don't worry, it's okay. Alright, so last one. Kalau produk C dan D, okay, so rate of disappearance, negative RC, negative RD. But in the reaction, C and D is product, right? They are formed. So the number will be a negative number. Don't forget, multiply again with stoichiometric coefficient. Multiply with minus RE. Okay, right. Last. Okay, I give you one example. So tadi saya terang, saya rasa memang susah nak faham. Lagipun dah pukul 6.30 memang susah nak faham. One example for easier understanding. Okay, katakan in this reaction, I have 2A reacting with 1B to produce 2C and D. Okay, so this is the equation. Okay, let's say dia beri kita rate of disappearance of A is 10 mole per liter minute. Dia beritahu kita kadar kehilangan A minus RA is 10 mole per liter minute. Apa maksud ni? Maksud ni untuk setiap 1 minit, kadar kehilangan A itu adalah sebanyak 10 mole per liter. Kepekatan tu 10 mole per liter tu akan hilang untuk setiap 1 minit. Means katakan awal kamu bekalkan 100 mole per liter, let's say early in reaction, you supply 100 mole per liter of A. Setiap 1 minit dia akan kurang 10. So 100 in 1 minute, 100 become 90, next minute become 80, next minute 70, so on and so forth. Itu berapa kehilangan kepekatan dia terhadap masa. So nak katakan kamu nak tahu juga kadar kehilangan atau kadar pembentukan spesies lain dengan masa. So, like as I said, kalau kamu tak tahu, mungkin kamu fikir kamu kena ukur kepekatan A dengan masa, kepekatan B dengan masa, kepekatan C dengan masa, kepekatan D dengan masa. Tak payah. Dengan hanya menggunakan pengiraan, kamu tahu the chemical reaction, kamu dah boleh kira untuk spesies lain. So, how do we calculate this? Okay. So, first of all, dikatakan, okay, as I said, rate of disappearance of A diberi soalan minus RA 10. Okay. They want us to calculate rate of formation of A. So tadi dia nak kita kira rate formation of A means what? Positive RA. Berapa positive RA? Okay, so positive RA samalah dengan positive RA kadar pembentukan rate of formation, but A is a product, A disappear. They don't agree with one another, that's why ada negative. So kalau tadi minus RA 10, positive RA negatif 10. Kenapa negatif 10? Sebab rate of formation, but A does disappear, does not agree to one another, the number becomes a negative number. Ataupun kalau kamu confused, kamu faham macam ni. Kita nak kira berapa pembentukan kan, berapa yang terbentuk untuk bahan A. Tapi bahan A tu hilang, sebab tu jadi negatif, nombor tu jadi negatif. Sebab kita nak kira berapa yang terbentuk. Dia hilang, so nombor tu jadi negatif. Kalau kita nak kira kadar kehilangan, berapa yang hilang, betul lah nombor tu positif. Sebab kita nak tahu berapa yang hilang, 10 yang hilang, nombor tu jadi positif. Nak tahu berapa yang terbentuk, dia hilang, that's why nombor tu jadi negatif. Okay, so next one, kita pergi kepada reactant B. Okay, dia nak tahu rate of disappearance of B. How much B disappear with time? So, negative RB. Kamu tengok disappear je, kamu terus tahu negative R. Formation, positive R. So, negative RB. Okay, dan kamu kena decide dulu. The number tu positif ke negatif. So, again, senang nak faham, nak cari kadar kehilangan B. Dalam tindak balas, B memang hilang sebab B adalah reactant. B is a reactant. I want to find rate of disappearance. B does disappear. That's why the number will have a positive sign. But don't forget, multiply with the stoichiometric coefficient ratio, B per A. In this example, B is 1. Tak tulis 1 pun dah faham dia 1. A, stoichiometric coefficient for A is 2. So it become 1/2 multiply with minus RA. Soalan diberi minus RA adalah 10. So maksudnya negatif RB adalah 5. Sebab 10 minus RA darab dengan B per A half. So you get 5. So apa maksud dia? Maksudnya untuk setiap 1 minit kepekatan B yang hilang adalah sebanyak 5. A 10, B hanya 5. Kenapa? Kalau kamu nak senang faham, kamu tengok tindak balas ni. 2A bertindak balas dengan B. So kalau A adalah 10 yang hilang, B yang hilang hanya separuh saja kan sebab 2A bertindak balas dengan 1B. So kalau 10A yang hilang, hanya 5B yang hilang. That's why you get 5 here because the reaction is 2A with 1B. Okay. Next one, you go to rate of disappearance of product C. So part ni yang biasa student akan sentiasa confused sebab dia tengok kadar kehilangan tapi dia tengok tu produk, so dia kat confused. So kamu jangan confused. Dia nak tahu how much C disappear. So negative RC. Okay. Then kamu tengok nombor tu pula positif atau negatif. I want to know how much C disappear. But C is a product, it is formed. They do not agree to one another, nombor tu jadi negatif. So negatif dan nombor negatif multiply with the stoichiometric coefficient, tapi stoichiometric coefficient of C over A multiply with minus RA, which is maksudnya stoichiometric coefficient for C is 2, stoichiometric coefficient for A is 2. So negative 2 per 2 multiply with your minus RA, you get actually negative 10. Apa maksud dia? Dia nak tahu kadar kehilangan A. Berapa A yang telah hilang? Tapi dalam kes ni C tak hilang, C terbentuk. Sebab tu nombor dia akan jadi negatif. Dia terbentuk sebanyak 10 mol per liter untuk setiap minit. Okay, so ataupun kalau kamu tak faham, kamu tindak balas ni 2A menghasilkan 2C. Maknanya 10A kena hilang untuk menghasilkan 10C. That's the easiest way to understand. I have to lose 10A in order for me to get 10B, and I have to lose 5B. I have to lose 10A to get 10C, and I have to lose 5B to get 10C as well. Okay? And the last one is product D. Product D nak tahu rate of formation. So tadi dikira rate of disappearance. All of a sudden now they want to find rate of formation for D. So rate of formation positive R, product D positive RD. So positive RD, the number is a positive number. Why? Because rate of formation of D is a product, D is indeed form. I want to find rate of formation, D is really formed, so the number become a positive number. Multiply with the stoichiometric coefficient D per A. Okay, so D per A stoichiometric coefficient dia adalah 1/2. Multiply with minus RA, which is 10, given in the question, you get 5. So meaning dia, apa maksud dia? Maksud kata lain, 10A kena hilang, 5B kena hilang untuk membentuk 10C dan membentuk 5D. Okay, so that's the easiest way to explain the rate of disappearance and rate of formation. Okay, so as promised, it's now 6:35. I think you already got. I think you probably find it very difficult at this moment, but it's fine. Okay, so for the next few days, you got no reaction class. We will continue next week. So if you have time, please make sure you just see a little bit. I will also upload the video on VLE for you to refer. So the only last thing before I finish the class, to give me the name for the grouping by tomorrow untuk mini project dan lab. But however, if you do not want, kamu tak nak cari, kamu nak saya carikan pun, tak apa, kamu just submit. Siapa yang tak submit tu, saya assume dia nak saya carikan. I can also form the group for those yang tak submit saya nama. Okay, so that's all for today. Do you have any questions? I assume kalau ada question, kamu interrupt saya. Tak ada question kot saya rasa. So I will see you next Monday. Thank you everyone for today and have a good rest.
Alright, you're welcome, Doctor. Thank you.
Thank you. Bye-bye.
Thank you, Doctor.
Welcome.